Hello and welcome back to a new video and a new session in our continued journey of trying to master geometry. And our today's agenda is going to be transversals across the parallel lines and the concept of pairs of angles being equal to each other. But before we start this journey, I'm assuming that you're comfortable with the basic idea of angles. You know that when two lines intersect each other, the vertically opposite angles are equal to each other. And you also know that the sum of angles on a straight line is always going to be 180 degrees. This is the summary of the journey that we have done so far, because we'll be using those ideas to further derive new ideas and keep doing and keep repeating that process, right? So let's start the journey. First of all, what do I mean by a transversal? A transversal is a line cutting across two or more lines. So say this is line L and this is line M and this is line N. So in this story, N is the transversal line cutting across lines L and M. Now the moment I do that, remember when one line was cutting another line, I was getting 4 possible angles. Now I've got 8 possible angles. So let me name them also: 1, 2, 3, 4, 5, 6, 7 and 8. So before we go into the theory of transversal cutting across a parallel line, we just want to become comfortable with a few terms, and the terms being corresponding angles. What do I mean by a corresponding angle? In this story, angle 1 and angle 5 are corresponding angles. They're not equal to each other in this particular story, but they're corresponding to each other. That means that they are like each other, they are similar to each other. And how are they similar? If I look at angle 1 and angle 5, both of them are above the line and on left of the line. So that's the common thing between them. So they correspond with each other in terms of position or relative position, right? Similarly, angle 2 and angle 6 follow the same logic. So angle 2 and angle 6 also are a corresponding angle pair. Similarly, notice angle 4 and notice angle 8. Both of them are below the line on left side of the line N, so they also correspond with each other. So 4 and 8 is also a pair. And similarly, 3 and 7 is also a corresponding angle pair. So if you understand this term corresponding, the logic is very easy. You don't have to memorize it. You just have to look at pairs which are similar to each other in terms of placement, relative position, etc. So this is the set of corresponding angles. Similarly, I can make more pairs, connected pairs essentially. I can look at alternate angles. First of all, I can look at alternate interior angles. Interior means these are the two lines, this is the interior of the two lines and these sides are the exteriors. This is in the middle of these two lines, this is the enclosed space, therefore interior. And alternate means one angle is on the right side of the transversal, the other is on the left side. Right and left is not very important, just that they are on the alternate sides. So if I look at alternate interior angles, angle 3 and angle 5 are a pair. Why? Because they are both on the interior and I am saying alternate and I see they are on the alternate sides of the transversal. Similarly, angle 4 and angle 6 are also alternate interior angles or a pair of alternate interior angles. If I just remove this interior and I replace with exterior, that means I am talking about beyond the lines, right? Not between them but beyond them. So I can look at alternate exterior angles. That means if I look at angle 1, the alternate exterior is going to be angle 7, because angle 1 is on the left side of the transversal, so I'm looking at an angle which is on the right side. So if I think of angle 1, the alternate exterior angle is going to be angle 7. Similarly, for angle 2 is going to be angle 8. Angle 2 is on the right side of the transversal, angle 8 is on the left side of the transversal, and both of them are on the exterior, so alternate exterior angles. And lastly, one more term, and don't worry about memorizing the term, try and see it on a common sense basis, it will be faster and easier, is interior angles on the same side of the transversal. So this is the transversal. These are the interior angles which are on the same side. Angle 3 and angle 6. Similarly, angle 4 and angle 5 also fall in the same category because both angle 4 and 5 are interior angles and they are on the same side of the transversal. So just recap the idea for yourself. When a transversal cuts across minimum of two lines, there are 8 possible angles created, and I want to look at a few pairs and the connection between them. So one such pair is the pair of corresponding angles. So we looked at angle 1 corresponds with angle 5, angle 2 corresponds with angle 6, angle 4 corresponds with angle 8, and angle 3 corresponds with angle 7. So these are corresponding angle pairs. Then we looked at alternate interior and try and understand the term. Alternate means on the either side of transversal. Interior means between the two lines. So alternate interior angles, angle 3 and angle 5. Angle 3 and angle 5 are alternate interior to each other, and angle 4 and angle 6 are also alternate interior to each other. I change the term to exterior, and then I see that angle 1 and angle 7 are alternate exterior angles. Angles 2 and angle 8 are also alternate exterior angles. So this is just understanding the term, because now when we move to the parallel line, we'll say stuff like corresponding angles are equal or alternate interior angles are equal. So we should know what these terms mean. That is the only use of knowing these terms and just getting familiar with the basic ideas.